All right, hi you guys. This is Mrs. Cook coming to you live from my classroom. Today I'm going to go over some examples of stoichiometry and mole conversion with you so that you have these at home to reference as you're working through homework or other study problems. So we're going to go ahead and start with this problem here that was on your mole conversion practice that we did in class. And we're going to go ahead and walk through it again together so that way you have this again for your reference. So our question here is asking how many molecules are in 720 grams of C6H12O6. So if you're in biology, or you might know because I told you this in class, C6H12O6 is sugar. And what we want to do is start by calculating the molar mass of that because we're going to need it, okay? So I've already typed out here my atomic masses for each of my elements. Now to calculate my molar mass, all I have to do is add these up. So for carbon, I have 6 carbons here. So I'm going to multiply 12.011 times 6. And we're going to add to that our hydrogen. We have 12 hydrogens, so we're going to do our 1.00784 times 12. And to that, we are also going to add, see if I can make this a little bit smaller here. There we go. We're also going to add our oxygen. So we have 6 oxygen. Oxygen is 15.999. We're going to multiply that by 6 because we have 6 of them. And once we multiply this out and add all of these together, we should end up with a number right around 180 grams per mole. So this right here, I don't know if I can highlight on here. I don't think so. Anyways, this number right here is our molar mass. So now that we have our molar mass, we can go ahead and start converting. Before we can convert to molecules, we have to convert first to moles. Because we started out with grams, we can't jump straight from grams to moles. We have to go we can't jump straight from grams to molecules. We have to go grams to moles to molecules. And this is all on your table that I gave you, which you should always use, and it should always be available to you when we're doing these problems. So I'm going to scoot that up here. Go ahead and start my next section. So first, I want to calculate grams to moles. I know that I have 720 grams of sugar, and I need to know how many moles that is. So I'm going to start with my 720. And if I look up here on my sticky note, I can see my formula for going from grams to moles. So I have my given grams. I have my given grams times 1 mole over my molar mass. And again, my molar mass is that 180.18 grams per mole that we just calculated. So once I do that math, 720 times 1 over our molar mass, we're going to end up with 3.996 moles. So I have done my first step of converting from grams to moles, but remember, we want molecules, right? This question up here is asking us for molecules. So we're not done yet. And now that I have my moles, I'm going to go ahead and convert that value, the 3.996 moles, into molecules. So we'll start a new section right here. There we go. Okay. So I have my 3.996 mole, and I'm going to multiply that by, you guessed it, Avogadro's number, which we all know is 6.02 times 10 to the 23rd. So I'm going to multiply these two values, and that is going to give me the number of molecules. We should end up, after we plug that in, with something around 2.406 times 10 to the 24. And our unit here is particles. So our final answer, let me make this part a little bit bigger, is this guy right down here. And I can check, I ended up with particles, so molecules, and it's asking me for molecules. And so I know at this point I'm done because I have the right units. We're going to go ahead and move on to the next problem. So this problem we did in class as we began to cover stoichiometry. We did it as an example together, and I'm going to walk through it with you again so that you have it for your reference. So in this question, it's asking us how many moles of mercury oxide. So this mercury oxide, that way we don't get confused right here, is referring to this. Our HGO is mercury oxide. We want to know how many moles of that are needed to produce 125 grams of O2. What we have to do first is convert our grams into moles. Since we need to complete our ratio in moles, we have to get moles before we go ahead and jump forward. To do that, to get from grams to moles, like we saw on our sticky note from the last slide, right here, grams to moles, we need our molar mass. So like I did last time, I put my atomic mass of my oxygen right here. For this problem, our molar mass is just for oxygen, but we have 2 oxygen, so that's going to give us about 32. Okay, so our molar mass for oxygen is around 32. What we're going to do now is convert our grams, 125 grams of O2, into moles. So we have our molar mass, we know our grams. So we have our given grams, 125 times 1 mole over our molar mass. Again, if we go back, we can see grams to moles, given grams, times 1 mole over our molar mass. So if we go ahead and plug that in, I'm going to plug it into my calculator right now. 125 times 1 over 32 should give us about 3.9. So I know now that I have 3.9 mole of O2. And now we can go on to the next step. So we've converted it. Now we can actually calculate how many moles of that mercury oxide are needed to produce 3.9 mole of oxygen. So to start out, we know that we have a 3.9 mole of O2. We want to know how many moles of mercury oxide are needed to produce that amount. So what we're going to do is we're going to multiply our 3.9 over our ratio. So our ratio is going to be the ratio of mercury oxide to oxygen. And that ratio is 2 to 1. There's an imaginary 1 here. So as we go back to plug this in, we're going to put our unknown mole over our given mole. Our unknown is mercury oxide. We don't know how much mercury oxide it takes to make 3.9 moles of O2. So on the top, we're going to have 2 moles of mercury oxide. On the bottom, we're going to have our known, our given mole, which is O2. We know we want to end up with 3.9 mole of O2. So we're going to put that part of the ratio on the bottom and that is just 1. And I should note that these are also in mole. So we're going to go ahead and calculate this, and that is going to give us our answer. So we have 3.0, excuse me, not 3.09, we have 3.9. We're going to plug that into our calculator, 3.9 times 2 over 1. And that is going to give us the lovely number of 7.8. And this is also going to be in mole because all of our other units were in mole. And this is going to be mole of mercury oxide, so that HgO. So if I look back at my question, it's asking me how many moles of mercury oxide are needed. If I look down here, that's where I'm at. So I know that this is my answer, and I am all done.